The border gateway routing protocol BGP is a heavy protocol which is very flexible to use wherever there is policies involved in path selection. BGP is a routing protocol like any other OSPF or EIGRP, but the specialty of BGP is to use in the environment where there are a lot of policies. This is very flexible. This is more flexible. See, one small cycle you can use to go to market. One scooter also you can use to go to market. Both are two-wheelers. But which is more flexible? Of course, scooter. Why? I can go fast and come fast. No strain or less strain compared to cycling. And I can do doubles, triples also if I have a scooter. But with a cycle, doubles itself is a difficult task. Both are cycle. Both have got two wheels. Both can be used to go to the market. But when you are tired, you always prefer bike. See, when you are tired, that's a policy. OSPF is also a routing protocol like BGP, but when there is more policy need to be applied while selecting the path selection to reach a destination, BGP is more flexible to use, easy to use than using OSPF or EIGRP. Can you put petrol in the cycle? You cannot put petrol in the cycle. Cycle don't have engine. Even if you want to put petrol, cycle won't support petrol because there is no engine in it. Likewise, if you try using OSPF in the place of BGP, you cannot. BGP has got that special engine, that special tank, all other things that can drive without taking your physical effort, pedaling. See, both are two-wheelers. Both are used for transportation. But you cannot replace cycle with a scooter. Same way you cannot replace scooter with a cycle. Meaning, when there is no petrol in your country, you will feel scooter as a burden. Because there is no petrol, the scooter will be too heavy for you. You cannot even pedal and it is useless. In that period, what is important? Cycle is more important. Cycle is more flexible when there is no petrol in your country. So what I'm trying to say is, OSPF is also good like BGP, but It has got its own place. In the place of BGP, you should not run OSPF. In the place of OSPF, you should not run BGP. Wherever there is more policies, only then BGP is good. OSPF is good wherever shortest paths need to be selected, not the policy based path selection. Here the only policy is I want a shortest path. Then OSPF should not use BGP. BGP will not select a path as per the shortest path. BGP focuses on attributes to select the path, not the metric like shortest path. So, both the protocol, both IGP and BGP are important in its own place. As I said, you can use cycle, you can use a bike. You won't use cycle when you want to go to long distance at the same time quickly. I want to go quickly and I want to travel long distance. Then cycle is not an option there. Cycle is not at all an option. Bike is the option. Next street. Just next street. And you have enough time to go. The next street your friend is there, parking is not so good there. What is the preferred one? Cycle is the preferred one. Because you don't even have parking there to park a bike. So you will best cycle there. Just the next street, not too far. And you have enough time to meet your friend. There is no rush. So if you take bike, it will become a headache for you. Going to next street in a bike and where there is no space to park, it's too much. பார்க்குறவங்க கூட என்ன நினைப்பான், இவனுக்கு காசு வந்ததும் வந்துச்சு, தலைக்கால் புரிய மாட்டான். இங்கே இருக்கிற வீட்டுக்கு என் வீட்டுக்கு வர்றதுக்கு பராம்பார் எவ்வளோ பெரிய புல்லட் எடுத்துன்னு புது பணக்காரன் அப்படின்னு தான் பேசுவாங்க. So every protocol is important in its own place. I'm not saying OSPF is bad and BGP is best. I'm saying BGP is best fitting in the place where there is more policy in path selection. OSPF fits within the autonomous system where there is no much policy, where you need a shortest path. In this chapter, we are going to learn about where BGP fits well and what all the terms or terminologies that we have in BGP routing protocol that we need to know. Let's get in. If you see this picture, there are 4 autonomous systems. The bottom one, where router A, B and C is your company. Enterprises, your company. Your company is given an autonomous system number 65500. Now, your company is doing a big business where the people around the world reach your enterprise's network and do some purchase, merchandise. For that, you have taken an internet connection so that customers can reach your network and do the merchandise, do the business online. ISPA is one internet connection you took, but to be on a safer side, you also took ISPB. Why? In case if connection to ISPA goes down, your customers will be able to reach you via ISPB and your business won't stop. Good idea. We call this type of connection to more than one ISP as multi-homing. Connecting to two or more ISP is what we call it as multi-homing. Why do we connect? To have high availability, which is called reliability. To have a reliable internet access. Even if one ISP fails to connect you to the internet, you will have another ISP to connect. So the connection to internet will not go down. Reliability. Next is performance. Path selection to common internet destination is better, meaning if you see this previous picture, to some customers, going via ISP A is better. For the customers here, customer alpha. Whereas the customer beta here, this is the shortest, this is the best. If you have only one ISP, then you need to go a long route. You need to go a long route like this. Because of more than one ISP, you can choose between the ISP to reach destinations. Right here we are seeing the reasons why we need multi-hopping. Multi-hopping is nothing but having more than one upstream, having more than one ISP as an upstream, so that if connection to one ISP goes down, you got another one. And through one ISP, few customers may be easy to reach, whereas the other customers are easy to reach via another ISP. So performance and reliability increases when we have multi-homing. Now, when you do this type of multi-homing connections, there are three different ways in which we learn the routes from the ISPs. See, this is multi-homing scenario. You can see the same picture of what you see in the previous page. Your enterprises 65500 is connected to ISP in the left and ISP in the right. Now both the ISPs, what they advertise a default route. They don't advertise precise routes for destinations. They simply advertise one single line of update default route. This is one approach. The second approach is ISPs advertise the routes for few destinations, not all, for few destinations. For example, here in this picture, only 10,000 prefixes. 10,000 prefixes. Only 10,000 route updates. For rest of the destination, a default route. You see the yellow line is a default route. The red lines are precise routes to the prefix. So this is another approach in the real world. First approach is what? Only default route is given by ISPs. The second approach is for some well-known destinations, detailed routes, and for all other rest of the network, only a default route. Thirdly, for all prefixes, you learn routes. From your ISP, you are learning routes for all destinations. What is the advantage? When you learn routes for all destinations, you can easily compare whether going this way is better or going this way is better for destinations. For some destinations, this will be better. For some destinations, this will be better. That's the advantage of learning routes for all prefixes. But the routing table of all these routers will be too big. See, ISPs have to maintain all the prefix because they are ISPs. But in enterprises, maintaining all the prefixes of the entire universe, not universe, the world which we are living in. Universe is very big. There are many portion of universe still not been even discovered. Man cannot reach there. There is only one life, and only in this earth. There is no other earth where people can live. Those are all made out stories. So I should not use the word universe. In this earth, you have millions of destinations, networks. Learning all those routes in the routing table will be a burden. So, only if you are having big ASR kind of device, big devices, you can accommodate those millions of routes. Yeah. So, sometime you may need it, then you can learn all of them. So these are the three approaches. When you have multi-homing, You learn full route. In the previous one, you learn partial route. For the rest all networks, you have default route. And in the previous one, only default route you learn, so that your routing table will be small. Did you understand things that I have explained so far?
Yes, sir.
Okay. So, what is an autonomous system? Border Gateway Protocol BGP works between the autonomous system. This protocol works wherever there is more policy, and between the border only we will have more policy. Between the borders we have more policy. So between the borders, meaning what? Between the autonomous system. Then we need to know what is an autonomous system. Here the definition is given: an autonomous system is a collection of networks under single technical administration. Is a collection of networks under a single technical administration. An autonomous system is a collection of network under single technical administration. Now, that is autonomous system. Within the autonomous system, what operates? IGP protocols like ISIS, OSPF, EIGRP, RIP. Whereas BGP is used between autonomous system. Now, whether it is IGP or BGP, every protocol exchanges a loop-free routing. You remember, EIGRP uses dual algorithm to provide loop-free network, loop-free routing. OSPF uses a router ID to avoid loop. Likewise, BGP also a loop-free routing protocol. BGP also, while advertising the update, those updates will never cause loop. Guaranteed loop-free routing. So in this page what we have learned is what is an autonomous system and where BGP works. BGP operates between the autonomous system. BGP is a path vector routing protocol. BGP is a path vector routing protocol. See, within the service provider network, or a enterprises network or a data center network, we will have IGP to announce the best path to the destinations, to the networks. BGP is not advertising any networks within the autonomous system. It is to advertise the networks that are coming from another autonomous system. When it advertises attributes along with the network. Very important to know. BGP advertises attributes, not just simply the network. It advertises attributes along with prefixes. So, what is the use of that attribute? We can define the policy. We can define the rules while selecting path to prefixes, destinations. So, BGP is not a simple protocol that advertises just the metric for the networks. It advertises attributes, not just metric, attributes. So far, we have learned that BGP is a path vector routing protocol and it advertises attributes. Now, BGP is a path vector routing protocol. The reason is it advertises the autonomous system those are all in the path from the source to the destination. That's why it is path vector. Every hop is one autonomous system. Every autonomous system is identified with a number. Those numbers are advertised along with a prefix. Autonomous system is one of the attribute, AS path attribute. Now, BGP characteristics. See, from this what we need to know is where BGP well fits. Where BGP is not appropriate. BGP is appropriate if you have policies. When you have multi-homing. When the packet passes through our autonomous system to reach some other autonomous system, which we call as transit. So these are the places where BGP is needed. Where BGP is not needed, when there is no policy. When there is single homing, not multi-homing. When there is less CPU and memory. When you don't have enough memory, when you don't have enough CPU, don't go for BGP because BGP needs a lot of memory and CPU. When you don't have multi-homing, if you simply have one single connection, no need of BGP. And when you don't know how to tune BGP using BGP's attribute, then don't go for BGP. We should go for BGP only when we have any one of this or all of this. Your autonomous system is a transit, meaning packet of some one autonomous system passes through your autonomous system and goes to some other autonomous system. Then there will be a policy allowing those alien traffics. You need BGP. The other one is you got multiple connections. You need BGP because there will be policy always. And you want to have a traffic engineering, I can say, directing via which the traffic should exit, via which the traffic should enter. These are all policies where we need BGP. So BGP is appropriate if you have any one of this, inappropriate when you have any one of this. As I said, BGP is a path vector routing protocol. It uses TCP 179 as the port number, very important. BGP uses TCP 179. Port number is 179. It uses TCP. It will not send any periodic update. There is a incremental and triggered update, meaning whenever there is a change, the change alone is sent immediately. And then to keep the neighbors alive, keep alive messages are sent every 60 seconds. As we already know, BGP has got attributes, not simply metric. This is very rich metric called attributes. You should not call it as metric in first place. We should call it as attributes. And because this protocol can handle more traffic with all policies in place, it is considered as an internet protocol. The internet protocol. All right.